Hello, welcome back. So, as a continuation of the last exercise on motion detection, so this one is a little bit more sophisticated by using motion tracing, as we say in this way, and then to use it to control the effect of a particle system. So let's start with our video image first. So this is our video image from the camera, and then the second thing we're going to do is how we can actually identify the motion that we would like to play around with. And for this one, and the first thing that we're going to do is we try to have a look how we can detect motion by comparing two frames. So in computer vision, I think the ideas of using the live video image to determine the motion, there's two ways. One is I can take a photo of an empty background and then I appear in front of the background as an object that I can compare with the static background to determine whether I'm present in this situation. And the second thing that we can do is we can actually take two consecutive frames and then try to compare them to see if there are any slight difference between them. So in TouchDesigner we can achieve by doing a cache. So cache is some form of memory that you can temporarily store your video frames or any TOP that with moving images. So by default it comes with 32 frame size, so you can reduce if you want to, and to see how you would like to compare the two frames. So in order to retrieve the frames, you can use the cache select. So you can just drag it here, and now you can have two frames. One is the latest one, so this is the latest frame, and the other that can be a few frames before. So how we're going to control which frame you're going to select is by using this cache index. The latest one is 0, so if you drag it, for example, -x, that is around half of the size of 16 frame, and you will see that there will be slightly delay of the motion that I have. And depending on the types of motion you would like to detect, so if you would like to detect a very fast movement, probably you do not need to have a very large negative number. So if you detect movement that can be very slow, that you may want to have a larger negative number. So that is the comparison of these two frames. Okay. And then the next step is you can compare two of them. So the comparison is by difference. So this is a very simple binary operation of comparing one pixel by one pixel of the two frames, and only display the value when there are differences between them. So for this one we can also just take the monochrome, that's the black and white grayscale image, which actually give you information about the changes in front of the camera. So if you can just sit still in front of the camera, you should see all black until you wave your hand or you make move when you see yourself. Okay, so the last step we would like to do is try to simplify this one by using a threshold that we can just have black and white. So to be exact, is transparent and white. So you can see that's only the area with movement will have white color. So you can actually also change this slider to determine, for example, which how much you would like to detect the movement. So for the situation we have very minimal and slow motion, that you can change it to a smaller value. So that is how we can work with those parameters. And then the next step is, given this, how can we use it to play around with the particle system? So there are two particle systems that you can work with in TouchDesigner nowadays. One is from the SOP, which can be quite tedious to set up. So the other one that come in pretty handy is in the palette browser with the particle system GPU, which is also faster in a sense that the implementation is done with the top TOP and the graphic processor, the graphic card, rather than in the CPU. Okay, by default, this is everything that you have, and the first output will be the top of the visualization of the particles. So we can always remove the bound to have this one, and if you would like to have slightly better performance, you can also reduce a little bit of the birth rate, and maybe you can also reduce the number of particles in the system. And then you can also design like what the particle should look like, and also the motion. Okay, by default the motion will follow the gravity, this -1. And also by default the particle source is in the ceiling. It's a rectangle up in the ceiling falling down according to the gravity. And our design is how we can make use of our body movement to generate particles rather than let them falling down from one location that is in the ceiling. And even though you can change quite a number of them and then use the chops to control the position, that probably that would be better for us to have this kind of bodily interaction. So luckily there's one option from here. There is the particle source you can actually put in at top. So in the past it's easier to use the SOP to directly assign a 3-dimensional location, but nowadays you may need to convert everything into a top in order to make changes to here. So how we're going to work on with this one is, we take a look at this, and then the first thing we'll like to do is to convert this into a 3-dimensional space by using an SOP that is a very handy but not commonly used command called trace. So for the trace, actually it accepts, surprisingly, is a top, so you can just drag this one to here. You may be able to visualize your own image in 3-dimensional space. So there are also a few parameters that you may want to adjust. So usually I'll remove the border, that probably won't have that extra line that connecting them, and in our case probably we do not need to use normal for the visualization. And then in the filter there are also further parameter that we can customize. Normally you can just leave it as default, be fine, but we can also like smooth the shape in order to get better response. So you will be able to see at this moment your image, your movement actually convert into three-dimensional SOP in terms of the primitive vertices and polygon. So that is something that happening in the screen of around -1 to +1 in the three-dimensional space. And if you take a look at this one, actually this is only 2D because you're tracing this image is actually in a 2D plane, in the XY plane. There's nothing in the EZ depth in this case. So now with the 3D information, so we are now ready to convert it back to something acceptable by the particle GPU, which is at top, that's 2D. So the conversion is a little bit indirect in a sense, so we need to first put it in a chop. So we only have two pieces of information right here. It's the TXTY and TEZ. EZs are always 0. It's basically TX and TY. And then with the TXTY information together with TEZ, we're now ready to convert it to a TOP. And then we take the data format. Since we have 3 channels, we're going to use up the 3 channel of R, G, and B and connect here. So that exclamation mark sometimes happen when you have no signals around here. So you are going to see something like this, which actually is one single line of pixel of RGB information that record down the XY position of my 3D rendering of my motion. So the next step is we have this. Actually we will be able to connect this one luckily to the first one, which will be the source of your particle. And then if you zoom in, actually you will see something that actually produced by itself from this tiny display. And we're going to further enhance it such that the result that we see here will be composed against your input video, and then that will be our ultimate design for this one. So in this case we will modify it later. So heat behavior I usually will do like the rebounds on contact, and then for the forces, and it already have the gravities around here. It's a constant downward movement, and initially I may also want to set up like it come with some upward velocity, and then with some turbulence here. And for the wind, that you can design how you would like to have the wind blowing in different direction, and according to the age of the particle or according to the velocity of the particle. And there's also definition of the turbulence that called the turning around of your particles. So we don't have optical flow here yet. So the other thing you can do will be like the rendering and material. By default is the leaf that we have around here, and then you can change it to something else. So the next change we're going to do will be the camera, and it comes with an internal camera. But if you would like to control the projection of this particle onto the two-dimensional video image, it's better for us to have your own camera that you can customize. By default it's perspective, but if you do this kind of AR type of overlapping with your video image, so we usually use the parallel projection for graphics that we play around pretty often in our last couple of exercises. And then this one we can just drag it to the camera to have a features that everything coming out here. So the next step is we might find that the particle seems to be quite big, that we can actually reduce the number and then maybe reduce the lifespan, and then we can reduce the size of the particle such that it won't block everything on the screen like this one. So that is something that you might want to put it on top of your video. So we come back to our composite, taking the video image and then try to overlap or overlay it and put it on top with our video, and then we can have a full screen display. You will start having something like this, which now you have your own image creating the particles, and we haven't finalized it yet because there's one more step probably we need to take care of, will be the width of this window. So we change it back to 1 such that the particle appear to be bigger, and also it cover the range of the video image properly. So you can now have a look at this one. I can also further change it to smaller such that we may have a little bit more of the particle coming out from here. And then in terms of the number and also the forces that we can further play around with this one to optimize the particle generated. So the logic of this one is actually your silhouette obtained from here because of our movement. So the movement will be in a white color, provided that there's comparison of two frames that make a difference, and then those silhouette will convert into color pixel information with the XYZ coordinate and put it back into the particle GPU using the same camera view and then place on top of each other and to create this. So if you would like to, you can also play around with other material and texture. So that is something that you can play around, like this one. So if you are friends of Frozen or Elsa, that you can sing along with your Let It Go with this kind of operation. So you may find that there's always your head because you are moving around, and it will trigger the emission of the particle at that location. But if you can sit still and move only your body, that you might be able to create the Elsa effect in the end. So if you want to, you can also add, for example, like feedback from here to have this kind of motion trail of this along with your video image. So that is more or less that we plan to do with this simple motion detection exercise. So for the particle GPU, I think this version they try to accept everything as a TOP. So if you would like to, for example, change the color of your snowflake, so you may want to add, for example, RAM that I can just customize it into one single line with color of your own choice, for example. Okay, so if you design this as your snowflake color, so you can just add it to the second inlet, which will modify the color of your snowflake according to the distribution here. So the result will be something like this. Okay, and I guess some of you may already know that we can actually play with the idea of optical flow in using the particles GPU, which is also a very handy palette that come in here, which I will just show you as a last update of this particular exercise in the palette browser. Optical flow, actually there's a two version. This one I believe, as I have double clicked to have a look inside, is done with GLSL. That's the shader programming rather than purely CPU based. So what you will do with this one is actually you can connect your video image here to your optical flow, and then when you I can take one output for the node, then we can visualize it a little bit easier. Then whenever you move around, actually it will generate two colors, and then one color corresponds to the vertical officially called the slope, kind of like the direction of the movement of the pixel, and one horizontal, one vertical in terms of two colors, and then use it to represent the flow of the pixel across the two frames in your video. So this piece of information actually you can connect back to your particle system as an optical flow input. And with this one you can create, I think not this one, I think the upper one, yes. That one actually will create some kind of wind-like effect, trying to blow away your optical, your particles according to the direction of your movement. The direction can be horizontal and vertical movement as well. So we can have a look at the effect. So you can move around with your body left and right. So you can now see, in addition to producing your particle through your motion actually causing the particle to shift to left and right and also up and down. So the up and down is not that obvious because we always have the gravity coming in the downward position. So that is how you can create this kind of fun for your Christmas or animated Christmas gift in this case. Okay, so that's how we work on with the final version. Then have fun to play around with the other options in particle system as well. And I think the next exercise we try to conclude the motion detection tutorial will be like motion tracking. So actually how you can track the movement of your motion across the two-dimensional screen. So that will be something we would like to explore in the next exercise. So until then, good day, have fun.